Hi everyone, so this video is about average rate of change, focusing mostly on quadratics, but we'll look at a few other functions as well. Sorry the board's a little hard to read, I know there's like a glare. So I wanted to start off with some kind of horrifying data here. This is just straight off of Google. These are COVID deaths in the United States, like per day. So as we look at this graph, there are definitely some things you notice. Particularly, it got really bad around May, early May, and then currently it's pretty rough as well. This was December 11th was when I took the screenshot. There were almost 3,000 deaths that day. So notice there are changes over time. For example, if I wanted to describe the change from around early May to early June, which is somewhere in here-ish, how would you describe that change? Maybe you want to use the tops of these graphs, maybe you want to use the bottoms, the minimum values, maybe you want to try to go straight down the middle. Clearly it was going down from early May to early June, but like by how much would you say? There are some bumps, it's a little messy, but generally we might say it went from around, I don't know, 2,000 is kind of in the middle here, and then by early June it was around maybe 1,000 or even 500. So you could say for that month it went down about 1,000 or about 1,500. That's definitely different from some of these other months, right? Like if we take a look at August, here's the 19th, so it was like around here is August. Notice that there wasn't a whole lot of change at all in August. June went up well, I don't even know what's happening here. I think the way they reported it changed on that day. August and September was also kind of just generally no change, kind of like no change in the number of deaths per day. There were still people dying each day, many people dying, but it was about the same each day. And then notice recently, which is not good, like let's look at November, which would be about this section here. This is a positive increase. So it goes from about 500 or 1,000 to somewhere around 2,000. So going back up about 1,000 or 1,500, something like that. I'm just using guesstimation and just kind of estimating the change, but what you'll notice is I can definitely compare these. The month of May, it was decreasing by about 1,000, whereas the month of November was increasing by about 1,000. The months of August and September, there wasn't much change. This is something that we call the average rate of change. It's at what rate is it changing on average. And it's basically the same thing as slope, like change in y over change in x. Like here, it's a negative average rate of change. It's a negative slope. Here it's positive, here there is none. Also, it's called the average because there are bumps all over the place. Like obviously it goes up and then down and then up and then down and then up a little more and down a lot more and all this stuff. But on average, if I went from here to here, it went down about 1,000. And so it's the average rate at which it's changing. And it depends on where you look at in the graph. Over here it was negative, over here it was positive. Another example I want to look at before we get into more specifics is, this is not real data, this is just a fake scenario with two guys named Juan and Antonio. The green graph represents Antonio, this one represents Juan. Before I give you any more information, I just want you to pause and think, what do you notice about this graph? And what are some things you wonder? So it tells us this is time in minutes. This is how much time has passed. And it says that this is distance in miles. So So you may be wondering, like, how far did they get? So here's a little more information for you. So now what do you notice or wonder? Okay, so some things I notice are Antonio starts out a little faster than Juan because he gets to 2 miles before Juan gets to 2 miles right here. But it looks like Antonio took a little pause because for a couple of minutes he didn't go any miles, and then he slowly picked back up, and it looks like Juan got to 12 or 13 miles before Antonio got to 4 miles before Antonio got to 4 miles. So, first of all, let's answer this question. How fast did they go during the first 5 minutes? This is minutes, remember? So 3, 4, 5 would be right here. So how fast did they go? Well, it took Antonio, Antonio went 1 mile in 5 minutes. Sorry, that's Juan. Juan went 1 mile in 5 minutes, whereas Antonio, the green one, went 2 miles in 5 minutes. What I basically just calculated is their speed, distance over time. And so this one would be like 0.4 miles per minute, and 1/5 mile per minute, 0.2. All right, so at the moment, Antonio is twice as fast as Juan because he made it 2 miles in 5 minutes as opposed to 1 mile in 5 minutes. Obviously, they didn't go that speed the entire time. So this simplifies to 0.4 miles per minute. Juan started off, let's do Antonio. Antonio started off not going super steep, but then it got steeper as we went. If I was doing 0.4 the whole time, it would have been a straight line right there. It would have been a steady speed. But he started off a little slower and then ended a little faster, and the average was about 0.4 miles per minute. Same thing with Juan's graph here. Starts off a little slower, but then a little faster, and if you average it out, it goes to about 1/5. Also, something you may have noticed, I don't know what mode of transportation you think this is. If you're going 2 miles in 5 minutes, you are probably not running. That would be world record setting pace. So maybe on a bike, scooter, car, I don't know. Take your best guess. What do you think it is? Let's see if that was it. Okay, so this might remind you of something, and it kind of looks like slope. It's like the change in y, the change in miles, divided by how many minutes have passed, the change in x. And that's literally what it is. It's just that we're calculating the average over a certain interval. Like if I wanted to calculate the average for this little interval, it would be kind of a small slope. This would be a little bit faster of a slope, or a steeper slope. This would have 0 slope, or 0 rate of change. So what we're talking about here is basically the same as slope. It's the change in whatever your y value is, divided by the change in whatever your x value is. Again, we call it average rate of change because it's the average over a given interval. So let me see here. Again, it's just the change in y divided by the change in x. We might also write this as delta y over delta x. Same thing. It's how much you rise over how much you run over whatever interval you're given. For example, on this graph, if I want to know the average rate of change from this point to this point, it goes up a little bit, but then down a whole lot. And so the average is still just the slope from this point to this point. It's the change in how much you went up and down overall over that period versus how much changed in the x direction overall over that period. So you went up a lot but down a little, so it's going to be pretty negative, this average rate of change. This is on your formula sheet. It says it in words. It says average rate of change, the change in the y value divided by the change in the x value. So that's change in y over change in x for two distinct points on a graph. So it's just, they got to give you 2 points like as a starting and an ending point for your interval. Keep in mind, this is the same as slope. Like it literally is the same thing as slope. So if you want to just use the slope formula, you can. Let's do an example. This is not a quadratic, but you'll get the idea. So what is the average rate of change from where x is -1 to where x is 3? X is -1 right here, so we're at this point. And then x equals 3 happens here, so that's this point. Note that another way of writing this question might be on the interval, -1 to 3. This and this are the same thing. X equals -1 is right here, x equals 3 is right here, so this and this mean the same thing, just by the way. Notice that this graph starts off kind of slow, but then picks up some speed. It gets steeper. So if I want the average from here to here, I'm basically just finding the slope of this red line. You don't have to worry about like figuring it out, just find the slope from that point to this point. It's the change in y over the change in x, which is the same thing as doing y2 minus y1 over x2 minus x1. So let's just look at the 2 points. How much does it change in the y direction? Let's use the points first. This is the point 3, 1. This is the point -1, -2. And so if I want to do y2 minus y1, 1 minus -2, and then x2 minus x1, I get 1 minus -2 is 1 plus 2, which is 3. And this is 3 plus 1, which is 4. And that's the answer. It's the slope, 3/4. You'll see that on the graph if you just count. To get from here to here, I go up 1, 2, 3. That's my rise. And I run 1, 2, 3, 4. That's my change in x. I run. All right, here's another example, this time a table rather than a graph. Kuiper uploaded a video to YouTube. V of t, that's our function name, models the number of views the video got as a function of time t in hours. That just means this is the time in hours, and this is how many views the video got. So after 5 hours, it had 70 views. After 20 hours, it had 500 views. So when did the number of views increase faster? Was it from 0 to 5? From 5 to 10? From 10 to 20? You have to be careful here because this, obviously that's the biggest jump. But this interval is bigger. From 10 to 20 is an interval of adding 10, whereas 5 to 10 or 0 to 5 is just an interval of 5 hours. So what we'll do is find the average rate of change. How much views did we gain per hour? The change in y per the change in x. The change in views divided by the change in hours. For the first bit here, we had 70 views in 5 hours. End up eating this, which is 14. So that's 14 views per hour. Then another 5 hours passed and we gained 110 views because 180 minus 70 is 110. And 10 minus 5 is 5. Basically, there were 110 more views divided by the 5 hours that have passed, which is 22 views per hour. So this was 14 views per hour in the first 5, and then we had 22 views per hour in this next 5 hours. Let's see if this one was even more. So in this one, how much did it go up? From 180 to 500, that would be 500 minus 180, which is 320 views. Divide that by how many hours have passed, which in this case is 10. If you weren't sure, you could do 20 minus 10, which is 10. And that is 32 if you divide those. So in this interval here, there were 32 views per hour. And so this one actually is the greatest. From time equals 10 to time equals 20, the views increase the fastest. So that would be the biggest interval there. From t, we could just say from 10 to 20. All right, last one. This one doesn't give us a graph or a table, it gives us just a function. If I want to determine the average rate of change from where x is 1 to where x is 2, I'm just finding the slope. And so that's y2 minus y1 over x2 minus x1. Here's the problem. To find the slope, I need 2 points, and I only have the x values currently. I need to find the y values that go with these x values. I need to find the outputs that go with these inputs. And to do that, just put them in the equation. So if I want to do where x is 1, put in 1 for x. So 1 squared plus 2 times 1, which is 3. And so that gives me the point 1, 3. Now let's do for x is 2. Put in 2 to the function for x. So 2 squared plus 2 times 2, which is 4 plus 4, so 8. And so that gives me the point 2, 8. Now I have full coordinates. I have the y values that go with the x values. Now I can just do the formula, y2 minus y1, 8 minus 3, over x2 minus x1, 2 minus 1, which is 5 over 1, which is 5. What this tells me is that this graph is a quadratic, so it looks like this. But from where x is 1 to where x is 2, it goes up an average of up 5 over 1 on that interval. And you could graph it and see that as well if you wanted.